All right, let's jump right into this explainer. Today, we are shining a massive spotlight on the hidden, hypercritical systems that literally run our digital lives. Every single app, every text you send, every random internet search, it all depends on this global infrastructure. And guess what? The way we manage the whole shebang is fundamentally changing right before our eyes.
So I want you to ask yourself a question. What if a data center could fix its own hardware before it even breaks? Just imagine this high-stakes scenario for a second. You're fast asleep, right? But halfway across the world, a critical server rack, one that's powering essential, massive financial systems, starts to overheat. In the past, that meant blaring alarms, frantic engineers waking up at 3 a.m., and the looming threat of catastrophic failure. But what if the infrastructure could just heal itself, mitigating the whole crisis in total silence, while the rest of the world just keeps right on sleeping?
Section 1. The Self-Healing Data Center.
Okay, let's really dive into this because this is where the engineering magic behind self-correcting global infrastructure actually happens. We're talking about a total, radical departure from traditional tech management. The core technology making this incredible feat possible, it's called the autonomous agentic loop. These advanced systems, they don't just react to problems. They predict thermal spikes and actively reroute global traffic. And the absolutely crucial part here is the timeline. They do this in milliseconds, long before the hardware actually fails. To put that into perspective, it takes you about 300 milliseconds just to blink. These systems are solving global catastrophes before your eyelids even open back up. It makes the old idea of a human frantically typing out manual incident responses look, well, completely obsolete.
So how does this actually work in practice? Well, a self-healing cluster relies on three major components working together in perfect harmony. First up, the system integrates the precise architectural schematics of the data center. It literally knows the physical layout of every single machine in the building. Second, it utilizes real-time telemetry. Basically, it acts like an incredibly advanced hypersensitive smart thermostat for the entire facility, instantly ingesting massive streams of data about temperature and performance. And then, by combining those physical blueprints with that real-time data, these systems form self-correcting clusters. They proactively manage the passive cooling and power distribution completely on the fly. They're seamlessly predicting and resolving issues without a single human ever laying a finger on a keyboard.
Section 2. Death of manual dashboards.
Now, what's really interesting about this is that it brings us to a major turning point in our explainer. It's a hard, concrete wall that traditional infrastructure management is about to slam right into, the year 2026. This year represents a definitive breaking point. The projected data volumes hitting global infrastructure by 2026 are going to be so massive, so incredibly overwhelming that they completely break the current human-led model. The sheer volume of traffic and the complex puzzle of routing it will simply outpace human cognition. There's just no way around it.
Because of those staggering 2026 data volumes, human-led network operation centers, often called NOCs, are officially rendered obsolete. Think about it. For decades, the absolute gold standard for global tech companies has been massive, dimly lit rooms filled with humans staring at giant walls of manual dashboards, just waiting for a red light to flash so they can react. But when you're dealing with the coming scale of global data, relying on a stressed-out human being to visually spot an error in a sea of blinking lights is a guaranteed recipe for failure. The scale is simply way too vast, and the stakes are just way too high.
Section 3. The Human Latency Gap.
And this brilliantly illustrates the real villain of our story today, the incredibly dangerous delay caused by human intervention in hypercritical tech environments. Let's trace the timeline of a thermal event to see exactly where the failure occurs and really understand why the old system is broken. Step 1. A thermal spike begins deep inside a server rack. Step 2. Under a traditional setup, a system alert finally triggers, but minutes later. Step 3. A human sees the alert, analyzes it, and tries to react. Actually, scratch that. Tries to mitigate the fallout. But by then, it is already way too late. Those crucial minutes lost between step 1 and 3 inevitably lead to hardware melting down and catastrophic global downtime. Bottom line, human reaction time is just too slow for modern data centers. When we contrast these two models side by side, the difference is absolutely staggering. On one side, you have human latency, measured in agonizingly slow minutes, paired with reactive scripts that only blindly deploy after things have already gone wrong. But on the other side, you have autonomous agents operating in milliseconds, driven by actual agentic reasoning. We are literally contrasting the sluggish, after-the-fact reality of human management against the lightning-fast preventative power of intelligent agents. One system waits for a fire to cause damage, the other removes the heat before the spark even occurs.
Section 4. The New Nervous System.
Let's move on and see how this all builds into the ultimate solution, shifting how we fundamentally conceptualize the machines running our world. We are making a complete shift from passive hardware management to a proactive, self-regulating ecosystem. Think of it using a biological metaphor. Your own human body regulates its internal temperature and heartbeat entirely on its own, right? You don't have to consciously think about it. It just has involuntary, instant reflexes. Well, that is exactly what autonomous agentic loops do for data centers. We are transforming static rooms of cold metal into living, breathing ecosystems with their own involuntary reflexes designed for pure survival.
This reality is perfectly captured in our source material. It says we are witnessing the birth of a proactive, intelligent nervous system for global infrastructure. So the crucial point here is that we have officially evolved past the era of human-led infrastructure. These machines aren't just blindly processing our data anymore. No, they are actively sensing, reasoning, adjusting, and healing the very physical environments they live in. Which leaves us with this final, truly profound thought to close out today's explainer. What happens to our digital world when the infrastructure that runs it literally no longer needs humans to survive? It's an incredible, almost science fiction reality, and it's being built right now. Take that concept, chew on it for a bit, and I will see you right back here for our next explainer.